Hello, and thank you for joining us for today's webinar, Expanding 3D Printing's Value Across Your Organization, Exploring Mojo's Many Uses. My name is Kim Kaloran, and I will be your host for today's event. Before we get into today's topic, I wanted to give you a brief overview of Stratasys and our technology. For those of you who aren't familiar with our company already, Stratasys makes additive manufacturing systems that produce prototypes and production parts directly from 3D CAD files. Stratasys manufactures and markets Dimension 3D printers, Uprint SE 3D printers, and Mojo 3D printers, as well as Fortis 3D production systems. We also operate Red Eye On Demand, which is an online rapid prototyping and digital manufacturing service. As I mentioned, my name is Kim Kaloran. I'm with Stratasys, and I'd also like to welcome our speaker today, Mary Stanley. She's worked with Stratasys since 1991, and she's a product manager for 3DP products since 2000. She's actively involved in the development and growth of the 3DP market with Dimension, Uprint, and now the Mojo line of products. So I'd also like to introduce the technology Stratasys uses, which is FDM. Fused deposition modeling technology is a patented process from Stratasys. It's industry-leading and uses production-grade thermoplastics. Basically what happens is a filament of thermoplastic material is heated up to a semi-liquid state, and then it's extruded through a nozzle, as you can see in the image here. The plastic is then deposited one layer at a time from the bottom up. So it's additive process, additive manufacturing. It's an easy, quick process, and the thermoplastic that's used is very durable. Today we'll be talking about the new Mojo 3D printer, just announced this May. Learn how you can get the most out of your 3D printing investment by expanding use beyond concept models and functional prototyping and into surprising applications throughout your organization, such as fixtures and finished goods. Now, without further ado, Mary, you've got the controls.
Thank you, Kim. Appreciate it. As Kim mentioned, we're going to talk briefly about our Mojo, the latest and greatest 3D printer from Stratasys. And Mojo comes as a 3D print pack. It's a complete 3D printing system, very compact and office-friendly. Comes with everything you need. You get the 3D printer, you get the software, the Print Wizard software to process your STL files. There's a support removal of cleaning system, which we call the WaveWash 55, and you also get a startup supply of materials to begin producing models immediately upon installation. One of the most unique features of Mojo is our new print engine concept, which is our material delivery system. The foil bag that you see on the right actually contains the filament of material. All Stratasys products use filament, and in this case it happens to be our ABS Plus. But what you're seeing in the photo on the left is how you actually install that print engine. Think of it like installing an inkjet cartridge. You simply snap in this case, what becomes the extrusion head, and you're all set and ready to go. So when you replace your consumables, you're also putting in a new extrusion head. Very innovative, something we're very, very excited about. The printed parts that come off of Mojo, as I mentioned, are ABS Plus material. It's a production-grade thermoplastic, durable enough for functional prototypes as well as end-use parts, and all of the models are finely detailed with layers that are 0.17 millimeters or 7/1000 of an inch thick. Very nice models. Office-friendly, really like a document printer. It's compact. I mentioned that your installation of consumables is just like an inkjet cartridge, very quiet, very clean system, and probably most importantly, no special training or dedicated operator is required to operate the system. I mentioned earlier the Print Wizard software, which is how we process STL files. Wanted to just give you a quick overview of what happens with the Print Wizard. So we're going to change quickly, and I will show you the Mojo Print Wizard. So just bear with us a minute here as we change. Bringing in an STL file is very simple. You can choose the particular model that you want to bring in. I'm going to bring in Mojo Man. Okay. And that'll pop open the Print Wizard software, and we've made this as very graphical in terms of being able to intuitively choose what you want to do with your particular file. You can bring in multiple files, by the way, as well. Now we see Mojo Man has come into our Print Wizard software. Just very briefly, we're not connected to a printer today, but you can choose a different printer if you have multiples. You have 3 choices of support styles, and again, we've tried to explain and graphically display what these different support styles represent. I mentioned the 7/1000th of an inch layer, and you can choose English or metric units for display. In this particular case, I can change the orientation of Mojo Man. We can have him do a face plant if we want him to, or he can stand upright. He can be on his head. But you also have the option here that you can manually orient in the X, Y, and Z. Again, very simple to use. You can scale your part. I want Mojo Man a little smaller in this particular case. Not too small, but you can do it with a sliding scale, or again, you can manually input. And then you can choose the number of copies. In this case, we've got room for 2. If I try and I can do 4. I can actually do 6. I can do 8 based on this particular size model. As I begin to do more, what you see happen here is we automatically created a second job. That's one of the key advantages of the Print Wizard, in that the software will do the work for you. I am going to reduce this down, so we've got a pack now of 8 Mojo Men. And then it's very simple to hit print, and your file will be sent to the host computer to actually begin printing the model on the Mojo printer. And then if we go back, I'll show you briefly the control panel, which shows you the status of the printer itself. And here we are with the control panel. Again, graphical, intuitive. In this particular case, the green light, the green bubble, as well as the green bars indicate that we have both model and support material, and the system is all ready to go. And then you would simply click print here, and the information will change, who submitted it, how long we expect it to take, how much material it will use, and the estimated completion time. So again, very, very simple for the user to step through the process and walk away and let the machine build as they're on to other things. The print pack also includes the support removal system. And in this particular case, we have the WaveWash 55, very small and compact as well, easily filled under any faucet, and start a cycle with the support material on your part, and then as the WaveWash 55 agitates the solution, there is a cleaning agent, we call it EcoWorks, that is used as well. And then ultimately there's your finished part. In this case, the chain. On the left, you see it with supports, and on the right, you see it once the model or the supports have been removed. But you know, whether it's a Mojo system or any other 3D printing system, what we really want to focus on today is how customers use the equipment within their organization. And customers often justify their purchase based on the needs of one department for using models within maybe one phase of the product development process. However, what we're finding so frequently is that it's not just within one phase or one department of an organization that these models can be used. Whether it's concept and program plans, the initial ideas, and a show and tell model to say, this is what I'm talking about, whether it's during the product design phase, into final development, or product launch. It's across phases and across departments that so often customers are using the system. Again, maybe justified for one reason, but once they bring it in-house, find many other applications within their organizations. And see here, we wanted to talk about some examples of different customers who have used parts off of 3D printing products for various phases of product development. In this particular case, Henk and I is a design firm located in South Africa, and they created a new type of high-torque, low-speed motor to work with low-energy pool cleaners. The motor was really a major departure from past design and really required rapid in-house prototyping. Henk and I used its 3D printer to build functional models, aesthetic models for the marketing department, full assemblies for fit testing, and finally working test units. For the low-torque motor, the firm sent 25 3D printed test units to clean pools in various parts of the world before they ever made an investment in tooling. This allowed them to get that customer feedback and make any necessary design changes to really be able to deliver the optimal part to their customers. We also find that schools in many, many cases are using 3D printing to teach basic design curriculum as well as the whole concept of start-to-finish product development. They purchase systems for their engineering programs, but then discover that it also can be useful in architecture class and even be able to print models to illustrate historical events. Schools have been phenomenally successful in embracing the 3D printing technology to really develop their engineering programs, and even at a middle school or a high school level, beginning to interest their students in the engineering curriculum. Very exciting. Another example that we have here is Leptron. They are based in Utah, and they make remotely piloted helicopters for military and civilian use, police departments, for instance. And the unmanned aerial vehicle, or UAV in this picture, is very lightweight and is composed of a series of nested sections that fit together in modular layers for various uses. This really is part of their concept and product design phases of product development. Leptron found during its testing that its 3D printed prototypes survived crash tests where the UAV is actually flown into the ground, as you kind of see pictured here. And Leptron decided to use the FDM component for its actual finished UAVs. In this particular case, Leptron saved over $250,000 in tooling costs. They saved 6 months in tooling time, and they now are able to make UAVs on demand and make design changes at any time. So this is an example of not only concept of product design, but actually going to a finished goods or end-use part example as well. And then our final case study today is Acist Medical, and they are located here in the Twin Cities in Minnesota, and they specialize in the design and manufacture of devices for cardiologists and radiologists. And they are using their 3D printed parts for not only concept modeling, but functional testing and manufacturing fixtures, as well as finished goods. The benefits of 3D printing for Acist really allows them to evaluate complex geometries to reduce part count. They are able to practice lean manufacturing with little inventory on the shelves, and it also provides them the ability to make changes to end-use parts after customers provide them feedback. It's been very exciting for us as we've watched the implementation of 3D printing throughout customer organizations, that they're using not only our proven FDM technology, they're embracing the full line of 3D printers from Stratasys, and certainly the Mojo 3D printer, our newest product, will fit right into this as well. And I'm hoping that today, whether you're looking at 3D printing for use in one department or many, or whether you're looking at for primarily use in one phase or multiple phases of the product development cycle, customers have truly found applications for 3D models from 3D printers throughout their organization and throughout all phases of the organization. This has been quick and it's been brief, but I hope that we've planted some seeds for you of how you may also integrate 3D printing throughout your organization and throughout all the phases of the product development process. I'm going to turn it back over to Kim at this point. If you're looking for more information, I think she has some sources for you. Kim?
Yeah, definitely. Thank you so much, Mary. Makes me think I want to contact our engineering department and get me one of these.
There you go. You probably could work a deal.
Yeah, good. So in a minute, we'll take any questions that the attendees may have. If you think of a question in the meantime, please be sure to submit it through the Q&A panel you'll find in your WebEx system here. I wanted to let you know that after the event today, you can find the recording of this webinar along with other relevant materials and request a sample part at www.stratasys.com/exploremojo. You can also find out more specifically about the Mojo 3D printer by going to mojo3dprinting.com. Okay, I am looking through the Q&A panel right now. Looks like I see a couple of questions have come through. Are you ready, Mary?
I am ready.
All right. Looks like Spencer has a question. What is the biggest part you can make in a Mojo?
The Mojo 3D printer can build parts up to 5 by 5 by 5 inches or 12.7 cubic centimeters.
Okay, thank you. Here's an interesting one from Santiago. He says, it looks like after it went in the wash, the chain can actually move. Is that true, and can you make moving parts in a single build like that?
Absolutely, and what enables that with our FDM process is our soluble support technology. The support material is a formula that will dissolve, as I mentioned, with the agitation. There's really 4 factors that impact dissolving supports, and there's time, and there's temperature, there's agitation, and there's chemistry, and all of those are delivered with the WaveWash 55. So in the case of the chain, you actually dissolve those support materials that leave you with a functioning, movable part. That obviously applies to other models as well, whether it's a working assembly or, in the case of the chain, you've got the finished goods in your hands with a very simple, clean support removal process.
Perfect. These are some great questions. Here's another one that came in from Carolyn. I didn't realize you can actually make end-use parts with this process. Are the plastic models strong enough to withstand high pressures?
Absolutely. And if you take a look at our Stratasys website, you're going to find a number of case studies where customers have actually used these as functional models, whether it's a paint gun, spray painting or whatever. You can withstand extraordinarily high pressures. And we have case studies, and I believe white papers as well, that show actual customers who have been able to functionally use the parts for their testing. Or even wind tunnel testing would be another example. So it's really across the board. It all comes down to that tough, durable ABS thermoplastic material that we're using to build the parts.
Great. Looks like we have time for one more question, and this kind of feeds off of the last answer, I think, a little bit. Brad is asking, can parts be post-processed and sanded and painted, et cetera?
Absolutely. I think in the Henk and I model we talked about, or in the case study we talked about parts that were used for marketing samples. And again, because it is ABS thermoplastic, all of the parts can be sanded, painted, milled, drilled, plated. It really is what you want to do with them. And the durability of the models makes it feasible for you to post-process in a variety of ways.
Great. Well, looks like our time is just about up. Thanks again, Mary, for your help with these questions. And if we didn't get to yours live on the call, we'll be sure to follow up with you via email afterwards. We'd like to thank each one of you for your attention during this presentation. And now I will turn it over to our operator, who will close out the event.